Okay, the rest of lesson 15, mechanical problems. I've got about 15 minutes to do this and about 48 problems. So I'm not going to talk much. I'm just going to, most of the problems here we've been doing right along quite a while. So if you need explanations, go to one of the first 7 or 8 lesson sets. All right, so the equational line through 3, -2 and 12, 5. So therefore, I'm going to use 3, -2 and write x minus 3 minus 2. The change in x is 9 units, and the change in y is up 7, and that takes care of that one. We're going to write that in slope-intercept form. So this is y equals minus 3/7 gets multiplied times x, negative times a negative positive 6/7, and 5 can be written as 7ths by using the number 35. So your answer, minus 3/7 x minus 29/7. If I make any mistakes, I got somebody who maybe can help write the time down and what ones I make mistakes on. Gonna multiply everything by 6. And if we do, we get a doubling of that number. That's still minus 18. This one is minus 3x, and this one is 6. I'll bring the 10 that way, which gets me 7x. I'll bring the 6 this way, minus 24. And I'm getting minus 24 over 7 as my answer. Next one. Oh, where's my card? Oh, God, Renee, you let me down. Hang on. Until I'm multitasking here. All right, come along with Renee the card. Come on, Renee. Okay, we're talking about some shortcuts for perpendicular and parallel. And I want them to pass through the point 4, 7. So I know I got an x minus 4 plus 7 over here. I got an x minus 4 plus 7 over here. Now, to get the original slope, you got to solve for y. And if you do, you'll find out that the original slope is 4/3. I already wrote it down, right? So you go ahead, solve this equation for y. You're going to find that you can put that number under here, change the sign, and that's your original slope. The perpendicular is the negative reciprocal, and it's staring you in the face. All right, and I suggest those of you who are getting this right, getting it right every single time, you can do it more quickly and easily now if you adopt what you're learning here to that problem. So we're doing f of minus 2/5. Again, work with fractions. Okay, I see minus 6/5. I got to make 9 something in terms of fifths. Saw the number 9, I wrote 9. Well, I think that's 45. And I think 45 minus 6 is 39/5. That one's done. Don't need that anymore. This is a conjugate. So if you look for the shortcut, 16 and 25 is 41. You're going to see 41 show up. We're going to do 4 plus 5i, 4 plus 5i. Okay, and let's do it over here. Okay, I'll remember to write the word center in a minute. 5 times 4 is 20. 5 times 5i is 25i. 3i times 4 is 12i. And 3i times 5i is 15i squared. That's all over. 4 times 4 is 16 minus. You're always going to get a minus because conjugates are going to be plus minus every single time. 25i squared. And I hope, I'm going to use the eraser here. I hope everybody knows -1 times -25 is 25. And 25 and 16 is 41. Kind of knew that. I'm going to take 15 away from 20. So that 20 is going to become 5. And I'm going to add those up and get 37i. Okay, and so I'll center, but you got an answer there, and I'm in a rush. All right, so now we're going to do completing the square to get a circle. And if you keep your eyes open and you look at your answers, you're going to find that -6, 7 is the center, and that's going to add up to a radius of 10. All right, now where did that come from? Oh, I'm just looking at this. I know I'm going to say x plus 6 here. I know that. So there's my -6. This is going to be minus 36. That's going to be y minus 7. So I just changed the sign and said 7. And I know I'm squaring. So that's going to be minus 49. And I know those numbers heading over to 15. If I move these numbers over, remember, you're pausing the video. If I move those numbers over, I get 100 over here. And that's a Pythagorean relationship we've looked at extensively. So the center is negative 6, 7, and I'm going up 10. If I go up 10, that's 17. Negative 6 should get us 17. Let's plug it in and see if it works. Negative 6, 17. You do the math. And you'll see you get 100. And there's other places that you can find just as easily. Vertex, all I'm looking for is the vertex. So I'm going to pop minus d over 2a into my head, which is minus 20 over 10. I know negative 2 is where I'm going to get a minimum. Minus 2 minus 40. If this isn't 20, I'm in trouble. 4 times 5, minus 7. You do that math, you get minus 27. And there's your vertex. Boom. Come on, Renee, let's go down here. Now, how do we write the equation? Based on the hx minus h parentheses squared plus k. Well, we got hk. We got x minus 6 squared plus 7. So how is this thing going to change? The change is right there when I plug in x. If I put a 10 in, it doesn't change by 4. This thing changes by 16 units. And 16 plus 7 is not 12. What plus 7 is 12? 5. That's that equation. How do we solve? We set it to 0, and we factor out what's common, which is x times 4x minus 723 equals 0. So x could equal 0, or x could take on the amount 723 over 4. Those are the numbers that in that calculation get me 0. That 2 goes in 43 21 times. Yes. So therefore, this will be minus 7i. Let's do it out. So we have a 7 times I squared 21 times. That gets me to 42 times I. Remember what I squared is. It's negative 1. And if you multiply negative 1 times negative 1 times negative 1, you do it 21 times, you're getting a negative. So there we go. Yes, correct answer. All right, you're welcome to do this out. You're welcome to do 5 minus 3i times 5 minus 3i. But if you get tired of doing that, your answer is 25. Your answer is 9i squared. And in the middle, you've got minus 15i doubled minus 30i. And that's going to be a positive every time, negative times a negative. But looking at this now, we know that number becomes minus 9. If I take away 9 from 25, 16 minus 30i is the answer to that problem. Same thing here. 49x to the 12 minus 14x to the 6 plus 1. Enough said, we just covered it there. I see a square root function. Well, square root function, let's just look at it. X, square root of x has friendly numbers. 0, negative 1 is undefined. We'll use null set. 0 gets you 0, 1 gets you 1, 4 gets you 2, 9 gets you 3, 16 gets you 4, and 25 gets you 5. It sure looks like the numbers on the left are going up faster than the numbers on the right. Numbers on the left going up faster than, each time. So we get that picture. So what do I have? I've got the most important number 0. So I say x minus 9. That minimizes this graph. I want a minus 2. This is where the change occurs. And when I drop 15 in, I get the square root of 6. And I know the square root of 6 minus 2 won't take me to 21. But 23 will. That's that function. We just started factoring the sum and difference of two cubes. Do you remember the conversation from yesterday? Working with the cube roots. Everything in the next parentheses comes from here. I got to get 8x cubed. The only thing that works is 4x squared, so I just got to square that number to get that. The only way I can get 125y cubed is 25y squared, and it's a plus. Just got to square that. And whatever that product is, get rid of it. Minus 10xy. I'm not going to take the time now to show that. The 6 terms and 4 cancel because I did that yesterday. And I don't have time right now. I got about 5 minutes left. All right, so what do we do here? Subtract 30, set it to 0, factor. X minus 6 times x plus 5 equals 0. I can see my answers of 6 or x could also equal -5. Both of those, I hope, work. A little bit harder factoring problem. Hope I've got this centered so everybody can see. I'm seeing 5x and x. And I'm looking at the factors of 8 that take me close to 18. I sure think 4 is 1. So there's 20, there's 2. I want positive 18 plus minus. X times x gets me x squared. I need -6, that's a -4. There's my FOILing. -2 times -4 is 8. I got to get to 7. I got to go down 1. 1 over x minus 2. Now that's the same thing as saying x squared minus 6x plus 7 divided by x minus 2 equals what? And why am I showing you that? Because the next time you might see it is in a calculus class where you integrate this with respect to x, and people don't have trouble integrating the answer, they have trouble getting that answer. So that's why we're practicing. When's this equal to 0? When x equals 0, or when x equals 4, or when x equals -6. All right, we got to get good at that because we're going to be graphing these soon, and we're going to be finding out when they're greater than 0 and such and such. So I want to envision this with perfect squares, like 4 times 6 times x to the 4th times x times y to the 7th squared. Okay, so I didn't need to change that. Y to the 14th. Okay, so I want to see that. All right, square root of 4 I know is 2. Square root of x to the 4th is x squared. The square root of y to the 14th is y to the 7th. So I got to get rid of the 4. The x to the 4 and the y to the 7 is now out here. And I still have 6x there. Cube root. Well, I see the cube root of 24 is 8 times 3. X to the 5th is x cubed times x squared. Y to the 14th is y to the 12th times y squared. Okay, I know the cube root of 8 is 2. I know the cube root of x cubed is x. I know the cube root of y to the 12th is y to the 4th. What I don't know is what the cube root of 3 is, x squared and y squared. Now, how many times does 3 go into 14? 4. How many times does 3 go into 5? 1. Okay, so there are shortcuts. Bingo, bango, bongo. So we don't make a sign error. 2 times z plus 2 is 2z plus 2. Plus 4, excuse me, getting tired. Z plus 1 times 3 is 3z plus 3. And this is z plus 1 times z plus 2. And I'm going to leave that because we might be able to cancel a factor. You never know. 2z minus 3z is minus z. I'm going to write it over here. I know it's off center, but I've taken care of that. But now I see 4 minus 3. 4 minus 3 is 1. So minus z plus 1 is what you should be getting, or looking at the video some more. Okay, just doing the problems out, just so Pig gets some practice here. All right, so we're hoping that folks can see the factored form. 4w is common. 4w times w minus 5 gets me the numerator. I'll bet you there's a w minus 5 here without looking, because it's a textbook problem, and it sure looks like it's w plus 3. Sounds like an oil. So w minus 5's divide out of the problem, and that's your answer. All right, I can see that I have a square root starting at -1, 0, and I also have -1, 0. So I have an intersection of 2 places. I should get -1 as an answer in some other place, but let's do the math. 3x plus 3 equals, you got to get good at binomial squaring. Got to get good at it. X squared plus 2x plus 1. I'm hoping that you're getting that term now. So we set it to 0. We got x squared minus x minus 2, which is x minus 2 times x plus 1 equals 0. Well, there's our -1. And there's our x equals 2. Sometimes you get extra answers, so you got to be careful. Square root of 10, you want to see that as the square root of 5 times 2 times root 5 and minus the square root of 10 times 5 times root 10 root 2. So pause the video long enough so that you can see that. I guess I could have written it here. Minus root 10 times 5 times root 10 times root 2. And I hope you know what root 2 is. 1.41. I asked you to memorize it since the start of the term. All right, so what do we have here now? Well, I can see the root 5 times root 5 is 5 times 2 is 10 root 2. And over here, I can see root 10 times root 10 is 10 times 5 is minus 50 root 2. Oh, did I really end up with root 2's? Because it sure looks like I got minus 40 now. That sure looks like it's minus 40 root 2. All right, so we're taking the shortcut on the absolute value now. We're going to subtract 9, minus 36. We're going to divide by 4, which is 9. The absolute value, however, could be 9 or negative 9. So now I'm going to add 2 to this. 11, I'm going to add 2 to this. Negative 7, I'm going to add up my answers, which is negative 4 divided by 2. Checks out. Those are symmetrical to the x value of the vertex. So my answers are 11 and negative 7. All right, let's see if I can get around Rene here. Sliding by you, Rene. Swinging back over. Taking me longer than I wanted. So I'm just going to show you the mechanics. Subtract 1, divide by 3. E to the means ln of. That's the inverse operation. That's approximately negative 1.1. And we're adding 4. But our answer is this exact answer. All right, that's done. 4 to the what gets you 1 over 32. Well, I know 4 is 2 squared, and I know 32 is 2 to the 6 because I'm a math teacher. What exponent gets me? That exponent. Sure looks like I really botched this. So this is negative 6, excuse me. So it looks like it's 5. Here I am telling you I know it, and I don't. So have a laugh on me. So minus 5 halves. So what are the operations? 4 to the minus 5 halves. Well, the first operation is the square root of 4. That takes care of that. Then I'm going to do the 5th power, and that's 2 to the 5. That is 32. And I'm going to do that to the negative 1, which gets me 1 over 32. All right, next problem. I'm going to take the cube root of 125, which is 5, and 5 to the negative 2 is 1 over 25. I'm looking for the common factor, which is 4. 4 squared to the x minus 1 equals 4 to the 3x plus 1. So I have to double that exponent. There's 2 parts to it. So therefore, 2x minus 2 equals 3x plus 1. I'll bring the 2x that way. I'll bring the 1 this way. Negative 3 should work. Okay, Rennie, let's move along. Almost done. So I want the roots. Well, I can see them. X equals 8 plus or minus the square root of 7/3. That's what gets me a 0. Okay, and if you want to prove it to yourself, put it in graphing form. Then check the steps out for solving that equation. 7, divide by 3, plus minus square root, add 8. All right, what's the inverse of this? The inverse of ln is e to the. But the first thing we have to do is start with a number. And that number is the output of this. So this is our number because we're making it a function of x. I'm going to subtract 3. I'm going to divide by 4. And I'm going to do e to the. I don't have time to check that with a number, but you should. That's an exponent. Logarithms are exponents. Where do you put exponents? On bases. So that goes on top of that to get me this quantity. So I am multiplying 3 times 1/8. I'm getting 3/8 as an answer. F of g of 2. So we got to do g of 2 first. Plug 2 in, you get minus 4 plus 5. Remember, you're not squaring. There's a difference between squaring the number negative 2 and subtracting 2 and squaring. We're subtracting 2 squared. We're doing that calculation. So minus 4 plus 5 is 1. Now we have to do f of 1. 2 times 1 is 2, minus 3 is negative 1. Okay, that one's done. You know, always modern technology. Go back and look at it. All right, I want to do some cancellation here, so I'm going to multiply by negative 2 because I like to add. That gets me 2x plus 3y equals 5. That gets me minus 2x plus 8y. 8y equals 14. I'm going to add up, eliminating that column. 11y equals, and I make a mistake. Thought I picked easy integer values. I thought I picked 2, 1, 1 and 1. No, I didn't pick easy numbers. So I'm just going with what we got here. If I made a mistake, I'll have to find it 19 over 11, which means I got to do the same thing now again to solve for the x's. So I'm going to pick a new number. I'm going to get rid of the y. So I'm going to multiply this one by 4 and this one by 3. That's 8x. And I hope I get division by 11 here. 8x plus 12y equals 20. I make more mistakes on these problems than anything, probably because I'm rushing. Minus 12y equals negative 21. All right, so that's going to be negative 1. This column is going to be eliminated. That's going to be 11. So 11x equals negative 1. So my x, I believe, is negative 1/11. I think I said. Okay, somebody can check me. If Yasser's still looking, I can count on him. All right. Okay, let's see what we got. We got minus 3 times the square root of 9 times the square root of 2 plus 3 times the square root of 4 times the square root of 2 minus 8 times the square root of 3. Square root of 4. Got a 4 in here. Square root of 4 times square root of 6. Sorry about that. So this is going to become minus 9 root 2 plus 6 root 2 minus 2 root 6. Well, I think I can put these two together and say minus 3 root 2 minus 2 root 6, because I can't put those together. They're not the same square root. And I hope you know what that is. Minus 3 times 1.41. Give another shout out to 1.41. That's what we're using for root 2. And root 6 you could have done by minus 1.41 times 1.41 times 1.73. And that's a good approximation for the square root of 6. All right, x squared plus 40. So x squared equals minus 40. So therefore, x squared equals plus minus the square root of 40i. And I hope you say plus minus 2 root 10i. Okay, we're just going to move the negatives into the other position. So this could have been written as 3x to the 4th. I'll move the y to the 5 to the denominator. We talked about it in previous videos. There's a 6. I'll move x to the minus 3 into the numerator. And I got y to the 7th. Now it's easy problem. I got a half times what? Times x to the 7th over y to the 12th. I don't need that one. All right, that takes care of that. I'm going to multiply this problem by 9x. See where it takes me. The x's cancel, I get 9. 3x goes in 3 times, I get minus 30. I don't see a cancellation of the x, so that equals x. So it looks like x equals minus 21. What do we have here? We just started talking about that in the previous video. In the previous video, I can see an ellipse. I can see it's centered at 0, 0. And I can see that I'm moving side to side 3 units. Oops, I went the wrong way. 3 is bigger than 2. So it's one of these. I'm going up and down 2, and side to side 3. Side to side 3 from 0, 0, from the origin. So if I go over here, 3 zeros should work. 3 zeros should work. If that's a 0, it's gone. If I plug in a 3, I get 1. The element of 6 leads us into the rules of logarithms. So 6 is equal to 2 times 3. I'm looking for E notation. E to the what? Well, I know 2 is e to the 0.7, and I know 3 is e to the 1.1. So I know that that is equal to e to the 0.7 plus 1.1. So e to the 1.8 is approximately 6. All right, x equals 2 plus or minus 5i. I don't like the textbook method. See if you can follow what I'm going to do. This is all about ax squared plus bx plus c equals 0. Trying to get that, so I'm going to subtract 2 plus minus 5i. I'm going to square x squared minus 4x plus 4. I hope I can square this and see 25i squared, which means my final answer is x squared minus 4x plus 29 equals 0. Now I'm going to do completing the square to get back to that. So I am gonna do x minus 2 squared minus 4 plus 29 equals 0. I can see that that becomes minus 25. I can see that this is x minus 2 squared, and therefore I can see that x minus 2 is equal to plus or minus 5i. I already did the square root. Last step. Last one. Y equals x cubed minus 6x squared plus 7x plus 3. What's the point of inflection? Well, it's gonna be minus b over 3a. That's our salvation. Minus b, 6 over 3 times 1. I know I gotta plug in number 2. And if I plug the number 2 in, I'm gonna get a 3-to-1 ratio of an opposite. That's 8. So that number, without looking, better be 3 times in the opposite. You check. Oh, yes. Plus 14 plus 3. I don't think I have to add 2 to 3. That's a constant. So that's going to be minus 16, minus double that. Plus 14 plus 3, plus 14 plus 3. And I think I'm getting a 2 gets me a 1. That's the point of inflection. Moves us towards graphing. And I forgot to even look to see if you could see everything. And I think you can. And I'm tired. I'm done. So I hope the video has enough practice in it to serve someone, because I don't have time to make another one. All right. Toodaloo.